Hello folks, I'm Ed Overstreet and welcome to the Night Sky Imaging channel. A month ago I took a stack of images of the Eagle Nebula M13 and I started processing that narrowband data on and did a YouTube step 1, and now we're going to go into step 2, processing the Eagle band, and we're going to pick up where we left off. So without further delay, let's head over to PixInsight. I apologize for the crazy mouse clicking issues I have here, but it is what it is. Okay, and let's kind of review what we did. We opened the batch weighted pre-processing script and we loaded our bias, darks, lights, and flats from down here, and then we did a run. We saved that data. When it was done, we opened up the master HA, S2, and O3 data files, and then we drizzled the images. And the reason is my combination of an ASI 1600 Pro camera along with the Stellar View 70 ST, which is a 330 millimeter field of view, produced a slightly undersampled image, and I'll show you what that undersampled image looks like and the reason why you drizzle. So this is the non-drizzled hydrogen alpha, and this is the drizzled hydrogen alpha. So want to do two things. We want to zoom in so we can see the effects of the drizzling. Let's go up here and look at some of these stars. I'd like to get a few more. There we go. And let's even zoom in more. And in order to get a side-by-side comparison, I'm going to drag this tab and I'm going to drop it into this tab, and we'll get a side-by-side look. So here's the drizzled on the right, here's the non-drizzled star on the left, and so it gives the effect of adding pixels. And by the way, that noise you hear is our sanitation truck has shown up, and I cracked the window because it was so nice out, and so you're hearing, it sounds like it's coming through my observatory. Anyway, you'll notice though we have more pixels in this star than we do this, and that's the effect of drizzling. It actually takes these larger blocks of pixels and divides them into like 4 blocks. And if you'll notice, let's even zoom up more and look at these blocks. And I'll drag this over and give you a, let's see, it may not let us do it, but I don't know why it wouldn't. There we go. And give us a comparable view of the same place. And just look at the size of these pixels as compared to the size of these pixels. So it almost as though it gives it additional resolution, and the algorithm is really assigning a pixel value to the surrounding pixels in order to keep artifacts from occurring, but that's the effect of drizzling. So we performed that function in the last video, step 1, and there's no need to perform it again, and that is the reason why we do that. What we're going to do today in step 2 is we're going to make sure that we have a decent crop of this image, and that any borders that have been affected by the dithering and also the drift that goes on in stacking a lot of images are eliminated. So let's go ahead and just bring up the hydrogen alpha again, and it doesn't look like it really needs cropping. Let's bring up the sulfur 2. And it doesn't either. So we got the hydrogen doesn't, sulfur 2, and I mean the oxygen and the sulfur 2. So we're just going to uncrop it, but to show the effects of this, in fact, it just dawned on me, there is a good chance, I can't remember for sure, that I already cropped this image back in the step 1, but at any rate, I'm going to show you how it's done. I'll click on the dynamic crop, and I'll just grab a side and bring it in ever so slightly because I don't want to eliminate too much of this data, and I'll drag it in from all 4 corners. Now, do not crop this. This is our base crop decision. This is the way we want to crop all of them. So don't crop this one. This will be the last one you'll crop. Just get it aside. And let's start with 03. Just drag that crop over, and it will have cropped that image, and then drag it over here to do the HA. Now the HA has been cropped. Now we can crop this one. Just make sure this is the one you actually perform the crop on using the dynamic crop tool. Just make sure you don't crop it until you've applied the process to the other images that you want to have the identical same size. Now all of them are. So we perform the crop feature, and it's time to combine those into an image. So we're going to bring up the I think I'm going to bring up the SHO palette. So to do that, I have a process that I've created, and I'm going to bring that up. It's a pixel math process where for the red channel I have S2, for the green channel I have a function, a formula or a function that I'm going to take 80% of the hydrogen alpha, so parentheses 0.8 times HA in parentheses, and I'm going to add that to 0.2 times S2. So I'm going to combine the sulfur and the hydrogen in the green channel, and the blue channel is just the O3. So you can just take a screenshot of that if you're interested in having this, and then you'll want to drag this process over and give it a name and add it to your list that's growing, that you will later save when you go down to process icons and save your process icons. So let's I've already got it saved. I don't need it. So I'm going to take let's say my hydrogen alpha out here, and I'm just going to drag this over to create I think you can apply this globally, but I'm not positive. So this is the show color, and it should be pretty green when we stretch it. And it is. So it's almost all green. So what I'm going to do is take this, I'm going to rename it, and it's going to be called SHO, although it's not exactly SHO. It is the combination of S and H are being used for the green channel, and we're going to have let's see, SH and then DC for dynamic crop. And so this is the name of this image now. I'm going to drag this off to the side and make a clone, and I'm going to take this image and I'm going to bring it up here, and I'm going to start building a stack of successive steps that I'm going to use. Each time I apply a step, I will save it and clone it to this stack so that I can always go back. Now, it's almost unnecessary when you have the History Explorer that you can go back and make effective changes, but I'm anal about all this stuff and I like it done that way. So it's just, you don't have to do it. I don't know anybody else that does. It's just a what I choose to do. It does make your projects really large, but it also makes it possible that when you want to come back to that project a year or two later, and at any one stage you can go back and pick up where at any one stage where you want to. So okay, so now we have a crop and a combination. We don't need the show color anymore. And one of the first things I want to do now is I want to perform a dynamic background extraction. Now I have DBE, and then I have DBE that's already been saved as a process, because it has, for me, a perfect application for this target. So I'm not going to use just that. I'm not going to use this process. I'm going to use this process instead. And you'll notice that it has applied a series of points that are around the nebula. And if I see any...
Okay. I found this on the web for a series of points that are around the nebula.
Well, there goes Siri. That's crazy. Turn my phone off. But if there are any big stars in here, I'm just going to shift it aside. Try to get it out of that field of view. But these are large boxes. I'll show you how large, and I'll show you how. I got this from Sean Nielsen. Works perfectly. He's with Visible Dark. It's a great YouTube channel. I've learned a great deal from Sean. Thank you so much. And the disabled radius is 255. That's huge. And samples per row are 10, and the minimum sample weight is 0.750. So these are great settings, and I don't normalize. I don't want the background model, and I replace the target image. That's just my choice. It's on this particular square or this alignment point, and you can see there are stars in it, but there's more background than there are stars. And it's Sean's thinking, and now it's mine too. It doesn't matter that there's stars in here. There's more background than there is stars. This alignment point, the same. So as you go through and look at your alignment points, as long as this point is dominated with background and not stars, then you're good to go. So at any rate, I'm going to save this. I've made a few changes. I'm going to save this process. I'm going to go ahead and apply it using division. Computer seems slow today. Okay, and now I'm going to delete it and restretch. Boy, it is running slow. And it has really removed the gradient. Now here's my process. I'm going to open it again, going to apply the same set of points. This time we're going to run subtraction, and I'm going to run it. And if I saw a gradient, I would do it again and again, maybe 2 to 3 times. But now we have the background gradients removed, and again, this is just a dawdle to use. It just works perfectly. Love it. So I'm going to take this process, because I may use it again. I don't know why I would on this, but I'm going to save it in case I decide to come back at a later time, a month from now, 2 months from now, as I save this project, and I want to start back with my show color and reprocess this, maybe using a new PixInsight tool. So I want to set the identifier, and I'm going to call this edges. No, I don't want to do that. How about just M13 edges, DBE. Alright, so now we have M13's DBE, and I'm going to set it over here where I have DBE. The last thing we're going to do in this step before we extract the illuminance channel, the last thing we're going to do in this step is we're going to open up the multilinear denoise, because we want to go ahead and apply a noise reduction process to this linear image, and it's called multiscale linear transform because it's generally used, not always, generally used just for the linear image before you stretch it. So I want to bring up the noise that I'm looking at, both luminance and color noise, and to show the effects of it, I'm going to create a preview, say about right here. And let's look at that preview. Actually, let's just go on over to create a larger preview. It's actually easier to see the effect if you do a smaller preview, but I'm going to create a larger preview, and you also want to unstretch this image. I need to go ahead and cancel that, unstretch it. Need to unstretch it first. Then we want a preview mask, and then add a preview. Okay, here's our mask. First we want to take a preview of it before we see the effects of it, and if you want to increase, if you want to protect more, right now we're protecting the stars and the nebula, and we're going to apply the noise reduction on the white area because this has already been inverted. Actually, you can see here where we've inverted it. So we want to protect the stars from smoothing and the nebula. I want some of the nebula though to have the smoothing algorithm applied to it, and so it's applying it now. It's recreating the mask now. So I've got, actually I have more of the nebula to be affected, so let's make it less, but let's keep the stars. We have more stars and we had more nebula. Let's make it less nebula protected, and hopefully we won't give up our stars. Okay, I'm even going to take it a little bit more. I'm more interested in the stars right now. I don't want to lose my I don't want to smooth the stars. Okay, let's do a little bit more. And this is how you make your mask, by moving this amplification slider. Just leave the smoothness to 2. Okay. Because I've lost some stars, I'm going to come back to 80, and that's where I'm going to leave it. Now you might want to create this multilinear transform setup. This comes from Atom Block. I highly recommend Atom Block Studios. It is a perfect place to start your adventure with PixInsight and to get as advanced as you want to get. Atom is a master PixInsight both developer and user. So we're looking pretty good here. Let's go ahead and turn our mask off, and when it stops, it's spinning up here, and so the computer is taking a while. I loaded an updated version of PixInsight, the last version of it, that's the 8.9, and I've noticed that things have really slowed down. And I don't know if anybody else is having that. Wow. Okay, it stopped, and so we're going to get rid of the preview. We're going to stretch the image. So things taking a long time. And now we're going to look at our preview window just to see the effect of it. And we're going to drop this onto the preview window. Well, it's taking a long time just to do the preview window, but there it did. Well, let's hang on. This is crazy. I may have to uninstall this and reinstall the prior version. You always get this kind of thing when you're doing a recording or a live stream. Well, you do want to see the effects of it. Alright, we got a we have it applied, and you can see the effects of it. I'm going to go up here to this icon right here, and I'm going to undo it and show you what it looked like before and show you what it looks like now. And I'm looking at my stars. I really don't want this to affect my stars, but we're going back and forth looking at the application of the noise reduction algorithm, and before, after, and before. And this, I think it has smoothened the stars some, but we can go back, we can work on the stars and select those out with a star mask and apply some sharpening to them. So we'll work on those later, but I did want to get the MLT ran on this image. So let's go back to this now and run the process on the entire thing. Okay, we got it done, so it looks a lot better, and I would recommend that you make your own process and save it for multi-linear transform, and do this before you stretch the image. It doesn't have to be in the order that I did it, but after I do a background extraction, I do like to run this and then make my luminance, pull my luminance out, and that's what we're going to do right now. And in order to do that, I'm going to come up to this icon, and I'm going to wait a minute. Wrong one. I didn't want to split the channels into 3, but I wanted to create a luminance channel. Go up and hit this icon, and we're going to call this Lum, and it has had the multilinear transform applied to it as well. So what we're going to do is we'll get rid of this preview. I'm going to rename this one. It has had the crop and MLT applied to it, and I'm going to drag this over for a clone, and I'm going to move this up to here. And so what we're going to do now is, I doubt I will run a background neutralization on this, because I don't think I need to, but I don't think I will either. I just don't think I need to. I look like I have a pretty even field of the same background. DBE did just a great job of removing gradients. Again, thank you, Sean Nielsen, for your tutorial on setting up a DBE on the edges. Okay, well, we're done with this, so let's put that aside. And for now, that's going to complete step 2. When we return for step 3, we're going to calibrate this using several different methods. We're going to use the photometric calibration. We're going to use just the color calibration tool, and we're going to use AutoColor by Hartmut-Bormann. So we're going to compare those 3, but I am a fan of photometric calibration, and I wasn't until I watched how it was done by Adam Block Studios, and I am now a real fan. So we'll bring that up on step 3, but guys, I hope you have a great rest of the day, and make sure you say something nice to someone. I know for a fact you're going to feel better, and I am 99% sure it'll mean something to them as well.